Morning, students. My name is Dr. B. Suresh Babu, working as a professor in Mechanical Engineering Department in MBR College of Engineering and Technology, Paritala. As a part of online classes, my presentation is for today's session is on functionally graded materials. If you observe this functionally graded materials, it is a part of the fifth unit. Fifth unit contains classification of functionally graded materials and memory alloys. For these two type of materials, we have to concentrate on properties and what are the preparation methods for these functionally graded materials, as well as for shape memory alloys and applications of these functionally graded materials, as well as shape memory alloys. I repeat once again, 15 unit contains of broadly two types of materials. One is functionally graded materials and second one is about shape memory alloys. For these two types, we have to know or learn about applications, properties, classification and preparation of these methods. For today's session is on functionally graded materials and how they are going to prepare and what are the applications of the and what is the nature of these materials and what are the properties. So these are the four things we are going to learn in this class: classification, definition, application and properties, and few examples of this one. Let us go to the topic of this functionally graded materials. Let us go from the beginning. Okay, this is about the introduction. As we all aware that from the fundamentals of metallurgy, if we observe, basically metals and non-metals will be there. In metals, pure metals have a certain importance, as pure metals does not satisfying the needs and desires of the industry as well as the society. From pure metals, we have derived an alloy metals or alloys, not metal and alloys. And what is an alloy? An alloy is a combination of two or more metals at a molecule stage is going to be called as a alloy. I repeat once again, an alloy is a combination of two or more metals combining at a molecule level is going to be called as a alloy. Why alloy is created? Alloy is created as pure metals does not able to fulfill the or not able to fulfill the needs and desires of the industry as well as the mankind or as well as the society or as well as for domestic purpose. So in that aspect, the alloys are developed. Next, after alloys, composites are developed. What is the reason for composites? The same reason, because as alloy cannot able to need the satisfy the performance and efficiency or need of a man or need of an industry or need of a domestic purpose. Therefore, composites are developed. What is a composite? A composite is a combination of a metal and a non-metal, and these are can be combined in different ways based upon the procedure how they are developed. The procedure may be, we can go for a a laminated procedure, or we can go for a casting method, or we can go for a reinforced method. For a laminated procedure means a wooden piece fitted to a frame. In casting means a silicon mixed in a aluminum or silicon mixed in a titanium. Next, a concrete phase means a reinforced phase means a pillar. These are the good examples to show how composites can be prepared. Now it is a turn for a functionally graded materials also to prepare. Why? Nowadays the need of the industry is very specific and the application is also very specific to satisfy the performance of a component. For that purpose, it made compulsory for a researchers to go for a new material such that where a specific application can be satisfied with a particular material, and that particular material has to be designed in different methods or in different ways. Those ways and those methods we are going to discuss in this class. Try to understand here. I am giving an introduction of a functionally graded material. If you observe the screen contains a pure metals and non-metals. Alloy is there. From alloys, composites are there. From composites, functionally graded materials are there. So what this shows, step by step, day by day, the needs of the industry, the desire of the domestic applications are very specific. To satisfy those desires and needs, we need a particular material for that application only, and we cannot replace another material. In that case, first from pure metals, alloys are developed. Combining of pure metal and a non-metal, composites are developed. From combination of a metals and combination of non-metals, functionally graded materials are developed. As pure metals are available in earth crust and non-metals are also available on the earth, in naturally it is possible. Artificially also we can prepare this one by certain process for the ore. Like that, alloys are not naturally prepared. Still, alloys can be manufactured by combination of metals. Some alloys can be naturally available in little proportionate of the other material when compared to parent material. Composites are the similar manner. For some are naturally composites are there, some are artificially prepared composites are there. On the similar grounds, functionally graded materials are also two types. One is going to be a artificial one, that is prepared by the man or prepared by the industry. Second one is about the naturally available functionally graded materials. So before going to the next slide, you can conclude that what is a pure metal and what is a non-metal differences. But this time you should understand that one. And already I have given the definition of an alloy, a definition of a composite. Now it is a turn to learn about the functionally graded materials. Let us have a definition of this one. Functionally graded materials are composite materials which are designed to present a particular spatial variation of their properties. Let us study deep in this concept. FGM are the composite materials which are designed to present a particular which are designed to present a particular spatial variation to their properties. What the meaning of this one is, these materials that are designed for only specific purpose. By nature, if you consider also, by artificial, if you consider also, the design itself is for a specific purpose. As I am telling from the beginning of this class, FGM, that is functionally graded materials, are for specific reasons and for specific applications. Next, this is usually achieved by forming a compound of two components whose volume fraction is changed across a certain direction. So to recognize, we have a differentiation with FGM with the remaining materials. These are of compound of two components whose volume fraction is changed across a certain direction. That means when we go along x-axis, or when we go along y-axis, or when we go along z-axis, the volume fraction is going to be changing from one part to another part in a one direction. For example, the toughness of a metal can be mated with the refractoriness of a ceramic without any compromise in the toughness of the metal or refractiveness of the ceramic. That means if toughness has to be improved for a metal, it can be possible by adding ceramic material without compromising the toughness. By adding this metal or by adding the ceramic also, toughness cannot be compromised, but the material can be made with a metal or a ceramic combination, or a ceramic combination with the metal. So that is how it is possible. The toughness of a metal can be mated with the refractiveness of a ceramic without any compromise in the toughness of the metal or the refractiveness of the ceramic. So that is so. The definition means they have a specific application and a specific reason in their properties. For example, the first FGM is developed in Japan in 1984 to 85 as a result of the space plane project. Although the concept of FGM is recent, many materials that fit the description have existed for decades. From olden days also, it says, knowingly or unknowingly, FGM materials are available for specific reason. The specific reason they have mentioned here, for example, if you observe, bones and teeth, seashells, bamboo tree, human skin. These are the few examples to explain what is the need of FGM. Bones and teeth. Bones are for toughness. Teeth are for toughness. Seashells are also very tough. Bamboo tree, which have a specific strength in one direction and very weak strength in another direction. Human skin, it has a peculiar nature when compared with remaining type of surfaces. So like this we can explain FGM examples. Artificially also some FGM materials are prepared. These are the few examples. The example shows for a space application project, a specific materials are designed. Now it is not turn to explain about the examples. In the due course of time, I will explain this one. Right now, you remember that these are designed for a specific applications and specific purposes. It can be possible in naturally available materials. It is also possible with artificially preparing methods. Next, for few examples of this are already I told skin, bone, and bamboo tree. If you observe the structure will be like this. If you observe the first one, that is the skin structure, sites of primary blister formation is there, simplex it is there. Here the structure seems to be another one. Here we have another type of skin, and here another type of net-like structure is there. If you observe, this one is sites of primary blister formation. A dominant EB simplex type of structure is available here, which is called epidermis. This is a recessive functional EB, dominant and recessive disotropic material here. These are called as a dermis. This is as the basement membrane anchoring tribes. So this is the line which we can see. So coming to this one, these are the technical terms. No need to explain, but this total structure shows how the skin is covering the bones of a body in a different layers. 1, 2, 3, 4, 5, 6. Total 6 layers are there. Coming to this one, bone. Bone is a very toughest part in the body. It is also have different types of patterns. It's called a cement line, Harbison canal, Loiconic, Lamellae, Caniculae. These are the examples to emphasize. There are different types of structures are available for FGM materials. If you observe, this is a bamboo tree. The structure is going to be like this. So this shows how these are going to be developed naturally. Next, why FGM? Already I am toying from the beginning of the class. For a specific reason, for specific application, we are going to use it. By this one, why FGM means better adherence of a protective layer. So FGM is going to be a layer which is used to protect the surfaces or protect the inner bodies with the help of the surfaces. The protection may be in terms of a hard hitting, corrosion, or it may be a shock proofing material, or it may be a withstanding high dynamic loading or impact loading. So these are the examples to emphasize the why FGM are needed. Next, minimization of interfacial stresses between different materials due to temperature variation. So second one is to reduce the stresses between one part of a metal to another part of a material. We can go for this FGM materials. That means FGM material can able to absorb the shock, or FGM materials can able to protect the material from heavy hitting, or sometimes it may be effective for reducing the stresses on the desirable component. This FGM is used for two purposes: to protect the parent material, at the same time to reduce the stresses on the parent material. For that one, we can use in a number of ways this FGM. So this is how the uses and purpose will be. Next, coming to this one, FGM allows better customization and tailoring of materials for specific tasks, more variety in material selection for engineering design. So if you observe the below example, stiffer at clamped end, softer at clamped end. That means a same material can be used for two purpose by changing pattern inside that material. That is possible for this FGM materials, that is functionally graded materials. So this is another advantage when compared to previous one. Next, classification of FGMs. FGMs may be compositionally or microstructurally graded. That means the classification can be compositionally we can able to divide, or based upon a microstructure also we can able to divide. FGMs come in several types depending on their constituents, that is ceramic metal or metal metal. Already I told FGMs are nothing but a combination of a metal with non-metal, or metal metal, or metal with another material which may not be a non-metal but it may be a ceramic also. So FGMs can be classified. One is on composites, other one is based upon the material. Next, depending upon the nature of gradient, the functionally graded materials, depending upon the nature of gradient, the functionally graded materials, that is composites, may be grouped into following types. One is fraction gradient type, shape gradient type, orientation gradient type, size gradient type. That is, the materials are fraction gradient type, shape gradient type. That means based upon the fraction, based upon the shape, based upon the orientation, based upon the size also, we can able to have a classification of FGMS. So these are the different structures that are possible for FGMs based upon the classification. For example, first one is based upon gradients, different types of functionally graded materials may be. Fraction gradient type means it looks like a sketch what we are going to see, and B sketch is for a shape gradient, and C is for orientation gradient type, and D is for size gradient. I think you can observe four parts are unique in its nature, on its or in its microstructure. So up to now, what I have explained is a definition of a FMG. What is the purpose of FMG? Classification of FMG, and how these FMGs can be identified based upon the diagram. So this is the how four FMGs can be differentiated based upon the sketches. Based upon the how these are layered, one is called as a continuous and second one is going to be called as a stepped. I think you can clearly observe the differentiation. For a continuous, it is mixing here like this. Continuous graded microstructure, metallic phase, metallic matrix with ceramic inclusions, transition region, ceramic matrix with metallic inclusions, ceramic phase. Coming to this one, metallic matrix, ceramic inclusion. Here, ceramic matrix, inclusion phase 1, inclusion phase 2. I think you can differentiate these two also. Inclusion phase 1, inclusion phase 2. This is up to metallic matrix and ceramic inclusion. Descriptively graded microstructures. So based upon a gradation, FMGs are classified into continuous and stepped. Examples of these materials are tungsten surface, that is hard and refractory material, copper surface, good electric and thermal conductivity. So by preparing a FGM material with a combination of tungsten and copper, these properties can be possible. One side we have a high soft nature and other side we have a high hard nature. Here we can use for one specific purpose, here we can use for another specific purpose. That is how we can explain this FGM importance. If you observe this one, butyl molybdenum Al6 Sa2O13. The structure is going to be like this: one type of layer, another type, another type, another type. So these are the only examples to show. Next, to prepare these processing methods, we have different types of materials are used along with different techniques. It consists of relatively thin sections or thin surface coating, vapor deposition techniques, plasma spraying techniques, self-propagating high temperature synthesis. So these are the three types: vapor deposition technique, plasma spraying, and self-propagating high temperature synthesis. Bulk FMG, it consists of volume of materials which requires more labor intensive process, that is powder metallurgy technique, centrifugal casting method, and solid free forming technology. So thin FMG is possible with above three methods, that is vapor deposition, plasma spraying, self-propagating. Bulk FMG is possible with the powder metallurgy technique, centrifugal casting method, and solid free from method. So by these students, till now I have explained the following summary. Let me have a glance on that one. First, I have explained why FMGs are needed. Explained about definition of a FMG. Explained about properties of FGM. Next, I explained about how the FMGs can be useful for a specific purpose. Next, I have shown few examples naturally available FGM materials, that is functionally graded materials, and the possible methods to prepare artificially FMG. So these are the introduction of this FMG. In the coming days, we will discuss about the incoming classes. We will discuss about the properties, applications of these FGM materials and the preparation method of this. Many of these preparation methods I have explained in first and second units only, because the heading itself shows you have already aware of this vapor deposition technique, plasma spraying, self-propagating. For bulk manufacturing of this FGM, we can use powder metallurgy technique. I think everyone know about centrifugal casting method, and salt free form technology is a new one. Okay, so by this I am going to conclude this class within a short period of 3 to 4 days. I will provide the notes for this fifth unit. Up to now, in Google Classroom code, I have provided the 1, 2, 3, 4 materials units. We can visualize that one by using this Google Classroom code GMTKRTQ All are small letters. 1, 2, 3, 4 units can be available notes. 5 and 6, fifth unit can be given within 3 to 4 days. This is the introduction only. Good day, students. See you all. Bye.
Very class అయిపోయిందా very